So my presentation, as you can see, it's a sponsored presentation. So there's going to be pictures of Corning bits and boxes and things like that. But in terms of the discussion and putting it together, it's really difficult because we've already heard that there are many ways to skin a cat, and there are a lot of people in here that's built really successful rural networks, and trying to put a kind of slant and to try and sum it all up in one presentation has been really difficult. So what we've done is we've taken our experiences in the UK, but in particular in the rest of the world, but focusing as well in Ireland as well. So we've had a lot of experience building the rural networks with MBI and in Ireland and supporting them with our products. And this is kind of putting trying to summarise the best we can the challenges that we faced when building those networks. So it's entitled "Simplicity and Speed Winning at Rural FTTx," which, given the previous discussions, has been is a kind of very much an oversimplification. So, what is rural? So UK, effectively, we have in England round about, classification wise, is around about 20% is deemed rural. In Wales, it's around about 30%. And Scotland again is similar, 30%. Northern Ireland is 30% as well. So there's a lot to go at, and the way we've kind of summarised it in the types of builds that we've supported is, and as we've discussed, you've got your kind of your hamlet or your village type builds, which once you get there is very, very similar to a standard urban build. And then you've got your distributed rural or your ultra rural networks, which are very spaced out, rural farms, very remote, and in limit, not even in clusters, just individual homes and businesses to connect. So there, I'm teaching you all to suck eggs here, or most of you to suck eggs, but there are a lot of challenges involved. Majority being that long distance from your central office, which gives you a really difficult time in terms of getting fibre out there and to deploy in a timely manner. You need more materials to get to where you're going to, which again increases the time and increases the cost to be able to connect customers. Infrastructure limitations, so the infrastructure that's there may not already be in place. So the duct network may not have been maintained for a good number of years. The footway boxes and poles may be in a bad condition. Sometimes they're shared, so you need extra permissions to be able to utilise those and deploy. And when you are getting out there, there is a potential risk for congestion with any kind of future overbuild that may be planned in the future by the operators themselves. So as well as that, you have challenging terrain on the environmental side. It complicates the installation, both overhead and underground. Obtaining permits is time consuming. Even in the little hamlets, you may have areas of scientific interest, and there may be some kind of things in place that stop you from deploying your normal method of deployment, such as closures. You may not be allowed to dig, and things like that in terms of these hamlets. So it's a real challenge when you're going into these places to be able to deploy successfully and quickly. And then finally, once you're deployed, you've got maintenance issues to get out there, to maintain and to repair. So what we've tended to see and support in terms of the hamlet type infrastructure is what we've said previously, and what the panel stated, that once you get to a hamlet, it's very much like an urban build. So we've seen predominantly overhead distribution, and which we use nodes and DPs and we use a range of closures, what we call the BPO range of closures, which enable you, which is a very, very flexible platform, enables you to configure them as you grow, as you need to, and configure them in the field, which gives your engineers more flexibility when you're actually deploying the networks. So typically, we see a secondary split, a distributed split, cascaded to the hamlet, in which case you would deploy around the town or around the village using very discrete evolved terminals, these push lock terminals, which give you a facade, a potential facade method of connecting customers, or they can be discreetly tucked away underneath eaves of houses and things like that. So we have a various range of solutions that give you the flexibility to build and to grow as you need to. And these kind of solutions are based on the same platform. So we, as you know, we or you may not know, but we are heavily involved in putting together hardened connectivity solutions, in particular in the UK, but across the globe. And we believe that this gives you a simplistic way of connecting customers quick, fast, and very, very easy to connect to customers. So we base the whole platform on the Corning push lock connector. And in terms of the closures can be configured to accept hardened connectivity, as well as normal splice or semi-hardened, as you can see in the top picture there, where it's got standard connectivity, standard SCAPC connectivity. So in terms of deploying, you know, there's no kind of golden bullet, silver bullet. Everything's different. Every kind of deployment's different. But in terms of our experience, in particular in Ireland, we kind of utilise this kind of platform of closures and terminals to support our customers in rural builds. The next distributed rural, which is the what we call in the ultra rural, is the remote farms and buildings and homes, is we tend to see it is a cascaded split, but again, a really flexible hardware solution enables you to configure it kind of on the go. So you kind of reduce the number of components that you need, you reduce the number of SKUs, and I'll come on to that a little bit later on. And it's one solution kind of suits the build that you are deploying. Again, you can use the same drops, and you can use the same cassettes and components within the actual closures themselves. This is much more challenging, as you see. You've got longer loop lengths, you've got longer drop lengths, and is technically really, really difficult to kind of plan around and implement. But this again has been used successfully in Ireland and in certain builds in the UK as well. And we hope to be able to support a lot of the people here in the future, kind of deploying this as they roll the networks out into the rural side of the country. So this is kind of the crux of it. So how do we kind of optimize the build? And the simple matter is you make it as flexible as modular as you possibly can. Any kind of network build is based around the functionality of the hardware that you use. The fibre itself, single mode fibre, is just a pipe. As we've said, you know, as some of the speakers have said, the fibre will be around, we're just going to change the boxes. Well, in order to change the boxes, you need to ensure that your hardware that connects the pipes can cope with any future transmission technologies. If we move into the WDM side of things, is it easy to swap out splitters for WDM modules? Functionality-wise, can your engineers build as they grow? Is it easy for your engineers to build? Because obviously, if it isn't, they'll tell you, and we've experienced that on a few times. But it all depends on building for the future. So put in place the hardware that will offer you the flexibility that in 10, 20, 30 or 40 years means you don't need to go back and rebuild. Because as Helen said, we're only building once, we're not going to build again. And this is what our range of products are based on. So whether it be point-to-point, centralized split, distributed or a cascaded split, one range of closures or terminals can cater for the whole remit of how you want to build. So we can splice. If you're going to continue with your conventional spliced network, we can support that. Pre-connectorized or semi-pre-connectorized, where you bring a cable into the closure, you open up the closure, bring it in and connect using a standard SCAPC or whatever connector type you want to use. This platform allows that as well. And recently we've just introduced kind of a fully pre-connectorized solution, a hardened connectorized solution that enables you to connect a push lock directly into the outside of these closures. So that means that you have you have the same platform, same cassettes, same method of deploying, but it gives you a full remit on how you want to deploy in a particular area. So, as I mentioned, the hardware selection is really key. Make it modular, make it flexible, and more importantly, make it network and cable transparent. So it needs to cater for any type of cable that you put in there and any type of network architecture that you choose to use. So, how can we help? And this is really, I mean, it's common sense, essentially. So you need to be able to deploy. You don't want every network to be bespoke. You don't want every network component to be special. So make your components and solutions interchangeable. Make it so that you can use underground and overhead solutions with the same component, and simplify the number of SKUs that you're rolling out your network with. Allow flexibility for your build teams, because your build teams will go out there and nothing is as built. Every time they turn up on site, there'll be some issue, a dig down, a crossing that wasn't marked on a map, overhead to underground transition. All these things are kind of banana skins that slow down the build and effectively cost money. We've found as well that cable storage is essential when we've built rural networks and supported rural networks. So have your components and have your hardware solutions capable of storing slack, storing loops of cable, but without being too intrusive. Make it as aesthetically pleasing as we can. A big lump of cable on a pole. The number of I live in on the coast in St Anne's, and all around they've built on poles and they've built issues, and they've stuck a normal dome closure with a big stainless steel, very shiny metal bracket on the side of a pole with 2 loops of cable either side of it, and it looks awful. It looks absolutely awful. So that's what we've tried to do with our solutions. We've tried to build in that slack storage. We've tried to make them slimline and aesthetically pleasing, as you can see that on the top left picture there. That's the new, what we call the EOT, the Evolve Openable Terminal, which effectively replaces one of these closures, and it gives a very slimline, a very aesthetic solution in areas where that matters, and it helps support the build, and it eases planning permission, eases the way that you can get permissions to deploy. We also found that what customers do tend to like is that they don't like to bring down the closure to do any work. So any kind of cable prep that you can do, not at height, makes a difference. That includes the actual deployment, the feeder and the distribution cable going in and out, but also the drop cable. So if you can just run a cherry picker down the route and plug in and then deploy that drop cable without having to open the closure or bring the closure down to floor level, that makes it an awful lot easier and an awful lot quicker. And then finally, on the expansion side of things, make it easy to work to. So have some space inside the closure so you can get your engineers can get your hand in, but more importantly, have it so that you can expand should you need to. We mentioned about just building once and the fact that, you know, how do we kind of future-proof the network? Well, you can plan it in, but also have the capability with your product selection and your hardware selection that you can have modules that you can easily clip in and easily connect. And that's what we're kind of building into our methods and our solutions for rural networks, that we have a very modular solution and a very easy one to kind of put together and to connect. So I've kind of raced through this, I've gone a bit quick. But the key takeaways from the Corning perspective on the build type, you know, deployment is now focusing on these rural networks. I think everybody's waiting for it to be the next big thing, but it's important, and it is going to happen, and it needs to happen. So it makes up around about 30% of the FTTP coverage in the UK. So it's essential that we do it well. Different kinds of challenges, varied landscapes, small villages, hamlets, and very isolated properties, and each one has a unique challenge. So we as Corning, we learned a valuable lesson in the early 2000s on this. So we came in all guns blazing with hardened connectivity. That's the solution. Everybody needs hardened connectivity because America did it, and America knows everything, and that's how they deploy. But we learned a very, very valuable lesson on that, in that it isn't the best way all the time, and everything's a balance. And that's one thing that we've certainly noticed when we've supported rural networks and rural network builds, is that balance. So sometimes you need hardened connectivity because you want to get in quick and connect quickly. Other times you want the flexibility to be able to engineer your solution on the hoof, and that's the kind of thing that we're trying to build into our products and into our solutions, and give you the support to be able to do that. And that's yeah. So it was a very valuable lesson for us in the early 2000s, that one. So as I mentioned, we can help accelerate the deployments. We offer an end-to-end solution. So we offer everything from your central office, POPs, cabinets, and it's all based on this modular kind of platform and modular flexibility that gives you that kind of comfort that you do have kind of one neck to ring should anything go wrong. So we can supply everything from what we used to say tip to tip, connector to connector. And if you build it modular, if you build it flexible, it does help accelerate, and it will reduce costs overall in deployments. And finally, on the new kind of products, the new kid on the block that we're showing, and please come and speak to us, and we've got some examples on the booth in the other room, is what we call the Evolve Openable Terminal, the EOT. And this is kind of a small, aesthetic, compact closure system, even though we call it a terminal. It's a closure system that enables you to kind of do a distributed daisy-chained network, and it gives you that closure that you can splice cables together, but it also gives you that add and drop functionality should you need it in rural locations. And that, alongside our BPOs, our closure platform, they all use the same cassettes, they all use the same kind of technology in terms of push lock. It gives you that overall feel that yeah, you have a solution that can cater for the majority of the builds that you encompass when you start to build. And that's it in terms of presentations, I think, from my side. Any questions? Tom?
I don't have a microphone, but I'm about to. Number one, I don't want to keep everybody from their morning coffee break, but I think it's worth. I've got one question that's almost a concern and a second question. So question one, I see in the presentation a lot of it was overhead. So my question is, what are you seeing as the demand for equipment that is overhead versus in the ground? Okay, and my concern is, I imagine it's going to be overhead is by far the most demand, but in terms of a long-term resilience, that's not the answer. Second one is, are you really firmly believing that connectorized solution modular throughout with many different connectors is the solution long term? And the reason I ask that is because we did a recent audit of all our fleet of Hellman Titan enclosures, and we splice everything. We splice the entire route, and everything's absolutely fine. We're only young, 10 years in, but I can see that lasting the test of time. What about push-fit connectors? You know, are they going to last 50 years? Are they? Question.
Answer yes. Yeah. So I mean, we don't do things lightly. We don't introduce these hardened connectors in particular. It's not a quick design and build and then ship and then sell. So these connectors go through Telcordia standards in the US, which are much more severe than any IEC standards that we do, and are deployed. And this, again, my old marketing hat on, from Alaska down to Australia. So they see all sorts of environments. On the OptiTap connectors, so the CBT type connectors, we don't see any issues, and we're not picking up any issues in the US at all in terms of those. So I understand your concerns. We've been through this process in particular with BT and OpenReach. I remember the days. They'll never have a connection in our network. We'll never have a connection in our network. Anyway, they eventually came round because they saw the benefits. And again, this is that balance. It's that balance of a fully spliced network or a connectorized network that potentially you could deploy quicker and maybe a little bit cheaper in terms of that project. So I
see that. I do see that, and I think as an altnet, we've got the option to train all our engineers to splice the entire thing. And others will be doing the same. But I do see that. You're not going to be able to afford to build an entire slice network across the United Kingdom. Yeah. So I get it. I'm just raising the concern really because there's a lot of overhead going on, and again, that's a cost thing, I think. But in terms of the long-term resilience and reliability and maintenance of networks, underground is by far the best, in my opinion.
Agreed. And you mentioned about numbers. We're seeing, and again, but we were deploying. A lot of our numbers come from Ireland and from other countries in Europe. We're seeing about 80% overhead versus underground. So another thing that I didn't bring up, and I should have done, is you mentioned about the connectorized. Another benefit of that is if you decide to fit or change the way that you use your splitters or whatever, the interchangeability of a connectorized solution is much quicker, and that's always been the case. But as you said, if you've got if you've got a really well-trained group of engineers that you go and deploy, and I'm not saying you're doing it on batch, but it's kind of like a batch type approach as opposed to a mass manufacturing approach in what we've seen, then the argument for connectorized versus splice is more difficult. Yeah, for sure.
Thank you for that. Thank you.
Anything further? Any further questions rather than coffee? Well, thanks all for your time, and appreciate it. Thank you.